So, starting with the head, if we're going to look at the digestive system, of course you have the oral cavity, and we have the pharynx behind it. The nasopharynx up here, oropharynx down to about here, and laryngopharynx down this far. It includes the front. This is the hard palate, the soft palate, and this little thing at the end that you see hanging down is called the uvula. Okay, and that's the tongue. Okay. And salivary glands. Somebody else had a test. Okay, parotid gland, submandibular, and sublingual is under the tongue, which is not shown here really. It's shown in the other head model, that one back there. Okay. Okay, so we're going to go down the esophagus. The esophagus has two sphincters, one at the opening and one at the end. And basically what starts happening in the mouth, we have mechanical digestion with the teeth, increased surface area. And then we also have salivary amylase to break down carbohydrates into lesser, not as complex.
Bicarbonate, right?
Not that I know of.
I just read it.
I just
in my physio book. So.
Oh, okay. Well, we're not worried about that. Bicarbonate in the mouth?
Yeah, that
okay.
seems...
Okay.
I know, it seemed crazy, but it was salivary amylase and bicarbonate, which I was pretty surprised.
There's supposed to be a lipase there, too.
And lysozyme. Yeah, lysozyme. So there are 4.
Okay, but anyway, the major thing here is salivary amylase. And you can take a slice of bread and chew it, and it should start tasting sweet as the carbohydrates break down. Okay, and a lipase, okay. So when we get the esophagus, there's no new digestion or absorption going on there. There might be some leftover from what was happening in the mouth. But it's just a way to get past, I think, the lungs and the heart to the stomach, okay? And we already have some stomachs already open here. So here, and that was the stomach also. So this is called the mucosa. This is the submucosa, muscularis, and serosa.
Do you need to know the 3 layers of the mucosa?
Which,
Lamina,
not really. I just want mucosa. Okay. Now, what was I saying? Now, food, first we need to chew it, okay, ingestion and chew it. It's going to be chunky. So you need to have stratified squamous. So it's stratified squamous all the way down through the esophagus. And why don't you look at a slide of the esophagus versus stomach where they come together? Because once we hit the stomach, the tissue changes to simple columnar because things now get kind of creamy, right? And what we call this stuff, it's a bolus of food, but it starts in the mouth. When it gets to the stomach, we're going to have stomach acid there. pH is less than 2. It's really acidic there. We also have pepsinogen, the inactive form of pepsin. We have lots of mucus too. So that kind of protects the surface of the cell of the stomach from being digested. So mucus, don't say mucous membrane, mucus, okay? Pepsinogen, which is inactive until it gets into the lumen, where we have hydrochloric acid. We also have tight junctions, so there's no leaks, and a very rapid turnover. Okay, so that answers one of the extra credit questions. Okay. And we have chief cells making pepsinogen, parietal cells making hydrochloric acid, and also making intrinsic factor. Intrinsic factor is important because it helps you absorb calcium in your intestines.
And B12.
Yeah. Mm-hmm. And B12, yeah, definitely B12. Maybe not calcium. That's vitamin D. Never mind. B12.
I just read this
No, B12.
like before
B12,
I came here, so.
that's important. Otherwise, you get pernicious anemia. Okay. The stomach's mainly a storage area, okay, but we do digestion of proteins especially. They can be damaged by salt and alcohol, okay, but luckily there's very fast turnover, okay. Ulcers, we now know that most ulcers are caused by a bacterium called Helicobacter pylori, okay, so a lot of the stomach ulcers and ulcers in the first part of the duodenum are caused by that. So nowadays you can just take antibiotics and cure yourself of an ulcer often. Okay. They used to go in and cut part of the vagus nerve. They used to give people all sorts of, antacids and stuff like that. Okay. Now, this is the end of the esophagus. It's called the fundus, the body, and the pyloric region. And what's special about the stomach? Something different about the stomach from the rest of the GI tract. How many layers of muscle? 3 layers of muscle, an extra oblique layer. So there's lots of mixing waves going on here. In general, we move things through the GI tract using peristalsis. But in the stomach, we also have mixing waves. How long the food stays there varies. It usually comes out in little batches, okay? Through the pyloric sphincter. Okay. What else? This is a lesser curvature, greater curvature. So remember, look at the slide that shows you esophagus and stomach together. So esophagus will have stratified squamous, stomach's going to have simple columnar. And it stays simple columnar all the way through the rest of the GI tract until we get to the anus, where things get chunky again, right? And then we get back to stratified squamous. Okay, what else do we want to say about the stomach? Anything else? I don't think so. Okay, let's put this away.